My name is Paulina, and today I'll be explaining about different types of functions and how to solve them. The first one we're going to do is linear function. So what is a linear function? Basically, it's just a straight line on a graph. There's not much rocket science. But yeah, we're gonna solve the first exercise, which, for example, let's make it fx equals 1 half x plus 4. Okay, so we have this problem, okay? I'm gonna make it a little bit smaller because it doesn't look that nice. Okay, so we basically got this problem. What are we supposed to do? The first thing we're gonna do is we're gonna change fx. Yes, this bad boy right here, we're gonna change it to y, and you'll say, why? Well, take me later, you'll see. Now, after we change for y, we're going to obtain what it is called the x-intercept. Basically, we're going to get x. So all we gotta do is solve the equation. So half x plus 4 equals 0. This 4 is gonna go over here, and it's gonna become it's gonna become a minus 4 because when it crossed the border, so it has to change money. Let's say, so it has to change money, and the money is a minus. Okay, so basically 1 half x equals minus 4. Then this 2 said, you know what, I want to go there too. So now it becomes a 1x equals minus 4 times 2, because the moment you divide and you cross the border, instead of getting a minus, it becomes into the opposite. So when you divide it, it becomes a multiplication. Therefore, minus 4 times 2 would be minus 8. Now what? Oh my god, where's the 1? Well, guess what? The 1 divides the minus 8, and then it becomes x equals minus 8. So we already have the x-intercept. We're gonna cross it with a cute little square. We already have the x-intercept. Alright? Yeah. Alright. Now we already have the intercept, the x-intercept. Now we're gonna get the y-intercept. Let me just put it right here. Intercept. Sorry for my handwriting. Anyway, so we're gonna get the y-intercept. Now, all we gotta do here is to write the equation the same. We're gonna write it instead the same, but in the x, where it's supposed to be x here, this bad boy right here, it's gonna become 0. Why? Because we're gonna find y. So 1 half times 0 plus 4. All we gotta do is just solve the equation. We solve it exactly how we know it. This one multiply this and it gives us 0 plus 4 equals j equals 4. So, oh yeah, I forgot. The coordinates would be 0, 4, and over here would be minus 8, 0. This would be the coordinates that we found. Now, how do you find the domain? Okay, the good thing about this problem is that you don't really have to bang your head against the wall when it comes to domain and range. That is because all the time it's going to be a minus infinite. Why? Because since the line is continuous, it's never going to stop. It doesn't have an ending. Therefore, it's going to be infinite. It's going to be infinite. So therefore, technically, domain and range have the same answer here. So we're just gonna put it here. There we go. I'm just lazy like that. Anyway, so this would be domain and range, which would be a minus infinite and an infinite. And then how do we get the CSAT? And the so basically we got j-intercept, which, fun fact, it's also known as it is a coordinate, an ordinate. The j-intercept would be an ordinate, and the x-intercept would be an abscissa. Okay, now we're going to graph this bad boy right here. Don't worry, my procedures are still here. Anyway, we're gonna graph this bad boy here. Okay, we're gonna do a simple graph, nothing too big, you know. I'm just crazy like that. I'm sorry. I had a lot of sugar today. Anyways, we're just gonna do a small graph here. We're gonna divide it to basics. 1, 2, 3, 4, 5, 6, 7. That's fair enough. And over here the same. Here would be a minus 8, 7, 6, 5, 4. No wait. 8, 7, 6, 5, 4, 3, 2, 1. And over here it's the same, so it's not important. Okay, the point is that we're going to use this bad boys over here, the ones we just made. So the point would be on minus 8, right? And we're gonna as well mark them on the 4. Why? Because the ordinate is a 4, and why on minus 8? Because minus 8 is the abscissa. Therefore, this is why we're going to mark these two points. Now we're gonna put them together. We're gonna ship them together. You're gonna live a happy life, holding hands from afar, and this would be the graph complete. And this would be the first result of what it is. Equation j equals 1/2 x plus 4. That would be the result of this linear function. And we're going to talk about what it is. Sorry for my lettering. Quadratic function. Now this one is a little bit different than linear function. Basically, instead of being a line like this, instead of looking like a line, it looks more like a B. I like to see it as a fox. Don't ask me how. I'll explain that point later. Now, anyways, why is it called a quadratic function? Because in different as the past one, which was a basic equation like that, you know, as we saw in the last one, it wasn't rocket science. It was a really basic equation. This bad boy right here is Well, as the name says it, you guessed it, my dude. It's hold on. It is a quadratic equation. Basically, you got a square root. You got a number 7x, plus a number that doesn't have not an x nor a square. All right, it's crazy like that. I know. It's going to be easy. Let's just do it together. So the first thing we gotta do, or what's something that I like to do, is to separate the equation. So we're gonna name it this one A, B, and C. This is optional, but I tend to do it because I get really confused easily. So we're gonna number this together. So basically the square root is A, the minus 7 is B, and the 12 is C. Alright? Okay, buddy. Anyways, so basically, over here, we're first going to find the vertex. I'm sorry. I had spicy food. Sorry. Okay, so first we're going to find the vertex, which is basically, the equation is like this. The vertex, it's supposed to be the middle. We're going to find the middle of the equation, so that we can solve it easily. I don't know. The point is that we're going to find the vertex. So basically, we're gonna use a magic formula that will get us through this pain, which would be h equals minus b times divided by 2 multiplied by a. Alright, this will be our magic equation. So all we gotta do is separate the numbers. We separated them. Now we gotta replace the values. So basically we got h equals minus b, which that would be 7. But look at that. It's a minus here, as well as it's a minus here. And you know the magic power rule. Minus plus a minus, it's a plus. Therefore, it becomes a 7. It doesn't have the minus. You'll thank me later. It basically becomes a 7. We're going to divide it by 2 by 1. Why 1? X will always be equal to 1. That doesn't mean the problem is solved, but conveniently it always has to be 1 when you don't have a value and you need to get that value. But that's another point. We're not gonna throw beef at math. I'm not gonna fight like that. So basically, we're going to make all the equation. Which would give us h equals 7 divided by 2, which would give us a 3.5. We found h. We found the h. GD. Oh boy, which would be. We found the first part of the coordinate of where would be the middle. But now we're going to find the second part of the coordinate. In this case, we're gonna call it a k. We're gonna call it a k. So basically for the k, you got the value that you already have. All you gotta do is, in order to find the other coordinate, all that you gotta do is replace the value that you had right here. This bad boy. Oh, sorry. This bad boy. We're gonna replace every single x with this bad boy. So basically, k equals 3.5 square root minus 7. Guess what? 3.5 plus 12, which would give us, we're going to do the whole thing give us 1 minus 1 quarts, which if we convert it to decimal point would be 0.25, but we're not gonna use that. It's not relevant. The point is that we have the vertex already, which would be 7 halves and minus 1 quart. Okay, so basically we already got this stuff, this bad boy. We already have the vertex. Hold on, my square is not perfect. It has to be perfect or I'll cry. But basically we have the vertex. Now the second part, this is my least favorite part because it's very long. I'm gonna be honest with you all. Basically we gotta find the x. We gotta find the x in the, I was going to say internship, but I forgot the word. Basically, we're gonna find x. Now this is where it gets its name. You know why? Because y'all remember that equation we were taught in, like, I don't know, 9th grade or something. You know, b plus minus square of b square minus 4ac divided by 2a. You remember this long equation that we used to make whole pages of? Guess what? We're gonna use it here. You never run away from this equation. It's always going to haunt you. So basically, all we gotta do here is replace the values. You're gonna say, well, it's not that bad. Well, it is not that bad. The problem is that it is really long. So basically we're going to do all the values again. 49. Oh, this is solved part, so we're gonna do it. We're gonna do the whole thing. So basically, so that you don't get confused, which would be 7, it would be 7 minus 4, then 1, 12. This is in order for people not to get confused. I'm sorry if you get confused. 2, 1. We're going to do the whole equation. Basically, the result would be minus 7. Minus 7. Yeah, minus 7. Minus 7. Oh. Plus minus 49. Minus 48. Divided by 2. Which would give us, what would give us? Oh yeah. Plus 7, because you all remember the rule, minus equals plus. Plus 7 plus minus 1 divided by 2. So basically we're going to divide this stuff. We're going to do alternate universes, like the ones you write on fanfiction, you know that stuff. I'm sorry, I need to get out more, but I don't have friends. Anyways, 7 plus 1 divided by 2, and then 7 minus 1 divided by 2, which would give us 4 and 3. Good job! We already have the x-intercept. I remember the word. That's awesome. So basically, the x-intercept would be 4, 0, and 3, 0. This is our magic one. Okay. Don't roll up your eyes at me, because the good part is that the y-intercept, it's a lot short. Sorry, I had a cold. Okay, the y-intercept, it's a lot shorter. You'll see why. Basically, all you gotta do x equals 0, y equals, replace the whole thing. That's right, baby. We're gonna replace the whole thing now. 0, 2 square plus 7 square plus 12. Okay, this is a completely different. Plus 12 equals y equals 12. So our coordinate is 0, 12. I'm not crying. I just have a very cheeky voice. This is the y-intercept. So basically, we already have the y-intercept, the x-intercept, and the vertex. Now we're going to make the graph once again, because we gotta graph this. It's part of the process. I know it's very tedious. However, it doesn't matter. It's okay, baby. It's okay. We'll cry later. Okay. Basically, I'm doing a very basic graph here. You can do something a lot prettier, you know. But basically, this is our graph. This is our graph. Yes. Beautiful. Amazing. Okay, this is our graph. So we have 12. Here we're gonna have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6. You know, all that stuff. So basically, we're going to mark the vertex, which, as we all saw, the vertex would be 7 halves and minus 1/4. It's gonna be a bit hard to do, but it's not bad. It would be between over here, around here, yeah, around here. Yeah, it would be around here, and then the x and y would be here and here. It's a 3 and a 4. We got lucky, boys. And the j would be 12, and that's why we have it like that. So all we gotta do now is put it all together. This time it won't be in the line, but rather a, a B, which, so anyways, also, before I forget, basically, in order to get the domain and range is pretty much the same thing I said before. The domain is this bad boy right here. It's this bad boy right here. And the range, here it's a little bit different. The range is the range is the first, it's H, no, it's K, the second number of the first coordinate, aka the second number of the vertex, which would be, this is some brackets, remember that. Numbers tend to have brackets. Minus 1/4, and infinite. Why? Because the fourth is here. The fourth is so good here. And therefore it has a stop point. That's why it's a bracket. It's supposed to be for close numbers, And then the infinite, you can see the arrow goes up towards space. We're gonna do what is a radical function. What is a radical function? As you heard on the name, over here it's a little bit more radical, because instead of having just a single equation, no. We have an x. We have a square root. Let's go! Let's go, buddy! Basically, this is our problem. We have to solve it with a square root. How cool is that? I'm not thrilled either, but anyways. Okay. Anyways, so basically, the first thing that we gotta do is just like the last problem, change from fx to yx, which would be y equals, you know, this, all this stuff. I'm just gonna copy paste. I'm a little bit lazy to do it. Plus, like, I don't know. I just don't wanna. I don't feel like writing today. Okay. So, okay. The good thing about this problem is that despite how terrifying it looks, I got terrified as well when I saw square roots. I hate square roots. Is that it's a lot shorter. So basically, we're gonna find the vertex. I ate the R, but it doesn't matter. Let's live it like that. We're gonna eat the vertex. Basically, we're just going to solve the equation over here with no square root, which would be 4x plus 8. All right. 4x plus 8. All right. Now we're just gonna solve it. We all know how to solve this kinds of equations. 4x. We did it last problem. 4x equals minus 8. X equals minus 8 divided by 4. X equals minus 2. So it would be minus 2 with 2y at 2 because this is the number. We're gonna put the number here over here, so it would be minus 2 with 2, you know, all that stuff. Now we're gonna get to the good stuff, the meat and potatoes, basically. X intercept. Basically here, all we gotta do is make the y as 0, which would be 0 equals, we're gonna put all the problem. We're gonna put it all over again. I'm just gonna copy paste it because like you, I have a computer and I can copy paste. Alright, I'm sorry, that was mean. Okay, anyways, so basically all we gotta do is solve the equation. This bad boy right here, it goes next side, and it would be a minus 2 equals 4x plus 8. Now the problem here is that when you put this on the calculator, you have a completely different number. Therefore, but the problem is that and the moment you put that number, the calculator gives you an error. You might panic with this, that's normal. I panicked the first time, but don't worry, this just means that there is no x. Yeah, we've been bamboozled all along. We tried to solve the x, and it turns out we never had. It was never there. Like, yeah, that reminded me of a lot of stuff. Well, this is not therapy. We're not going to talk about that right now. Anyway, so basically there is no x. Now, okay. Now, how about the y? Is it going to disappoint us just like x did? No, I don't think so. Well, let's be positive. Anyway, y-intercept. Basically, we're just going to solve the whole thing. Now, instead, the same thing goes here. We're going to replace 4x with all the x's with zeros. 0 plus 8 and then b plus 2. 2 plus 2. So y equals square root of 8. Sorry, square root of 8 plus 2. Now y 2 plus 2 square root of 2. Y equals 4.82. And this is the j-intercept, 0, 4.82. Shut up, I'm recording a video. Anyways, 0.82. Now, here the domain and range is a little bit different. Basically, it is the domain and the range is the first number is the vertex. The first number of the vertex. So that would be a -2 in both cases. It's a bracket, okay? Don't get it all confused. -2 with an infinitive. Why? Because the line is continuous, therefore it never has an ending. Now we're gonna do the graph all over again, alright? Don't roll your eyes with me. All these problems have graph. You signed up for this. I didn't do anything. Anyways, what's up with that southern accent? I should stop watching television. Anyways, so basically, we're not gonna put any thought. We're not gonna put any thought into this. You know, all we're gonna do is all this graph is gonna be until sorry, I fell. Until -5, 5, 5, -5 as well, and 5. All of these will be 5. 4, 3, 2, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, well, we have it all complete, all marked together. Now all we gotta do is put the points. We're gonna mark the points based on the graph. So basically this one, it is 4.82, so it would be around here. I'm gonna make a big guess on this one. And then the second point would be in -2. Sorry. In -2 with 2. Okay. Remember that we don't have an x in this one, so we don't have to put an x. That's a good thing. So 1, 2 would be around here. Let's put it around here. So we're just gonna put the lines together, and you can see that this looks like a vertical launch. Yay! So basically that's it of the problem. The radical function is relatively short, and yeah, we're gonna go up with the last bad boy, rational function. Alrighty, mate. What's up with that southern accent? I just stopped watching television. Anyway, so rational function, this bad boy here is the, ironically enough, is the most intimidating ones. For example, this one that looks like this bad boy. Looks like this. That looks like a division. It looks quite intimidating. It gives me flashbacks to equations and how I cried before I sleep. So we're not gonna get into that. This is not therapy. Anyway, so we're gonna find, instead of the vertex, we're gonna find the vertical asymptote. An asymptote? Oh, by the way, asymptotes are two lines that are together. Like they're exactly the same, but they never touch. Unlike parallels, they're completely far apart. They're completely far apart. They never touch, but they're pretty much the same. However, they're far. But asymptotes are near each other, so near they could touch each other, but they just never touch. That sounds kind of like star-crossed lovers. I kind of want to make a story based on that. It's an interesting concept, I'm not gonna lie. Anyways, vertical asymptotes. So good thing here is that all we gotta do here is use the equation down here. So it would be x minus 7 equals 0. And good thing we don't have to make much. X equals 7. So this is all we have. I know, right? Quite interesting. Quite interesting. Alright, anyways, that's like the Ellen intro. Now we gotta find the horizontal asymptote. We're gonna put it like this. My teacher used to do this when she didn't want to write. So basically, we're gonna find the second one. We're gonna find the second one, which would be 2x. X. Alright, we have this bad boy right here. It would be 2 halves 1, which gives us 2. Why? Because 2 divided by 1, you cannot do it, so it becomes 2. Now, with these values in mind, with these values in mind, we're gonna find the coordinates that will help us make the lines. So all we gotta do now, this is gonna be a bit of a stretch, but this makes life a lot easier, believe me, is a small table, which would be x, y. We're gonna put random numbers on the x part. Let's put 8, 9, 6, and 5. That's good. Now, in order to get them, basically all you gotta do is you gotta do the equation. You gotta do all this equation, but replace it with the number. For example, 2a minus 1 equals 8. 8 minus 7, and the result would be 15. 15, no, exactly. Now we're gonna do, and you're gonna keep going like that, going on and on like that, like the song. So we're gonna skip that because it's a bit long. I already have the answers on my side, so all the problems solved, so that I don't lose that much time. So basically we already have J. So all we gotta do is graph. This is a hard part. This is a hard part because it is a little bit complicated. It's a bit convoluted to make that graph. So basically let's just put it all like this. We're not gonna put any values or anything. This one would be 15. This one would be 8. Yeah, it would be 15 as well. Everything will be 15. 15 and not 11. No. Oh well, yeah, 15. 15 is good. 15 is good as well. Minus, all that stuff, that good stuff. So basically, we're gonna mark what we found here, 7 and 2. We're gonna mark it. So basically, 7. 7 would be around here. 2 would be around here. So therefore, I'm gonna mark these lines. This sort of like guidelines, invisible lines that mark the domain and the range. We'll get to that later because I wanted to get to the graph first. And we're gonna change colors. Holy moly, we got fancy. And all we gotta do now is just mark it based on the numbers we had here. Because it's an 11. Here, because it's an 8. Here, because it's an 8. Here, because it's a 2. And this is pretty much the points we got. So all we gotta do now is put them together. We have finally the mark. Sorry, we already have the line together. Now here, the domain and the range, and the range. Sadly, it's not like we did on previous classes. That's perfectly fine. Not all things have to be this perfect. So basically the domain and the range is the two numbers that we find on the vertical asymptote and the horizontal asymptote. As you can see, they're both real numbers. So this would be all real numbers, all real except 7, and over here would be the same, all real except 2. And that would be the whole explanation of rational functions, radical functions, quadratic functions, and linear functions. Thank you very much for sticking around, and we'll see you all later, I guess. Thank you.